Hey, what's up, y'all? Welcome back to Three Shapes, Four Colors Part 2. In this video, we're going to take a look at how we can use our own variables to control things in our sketch. We're going to look at how we can get some mouse input. We're going to learn how to rotate shapes in our sketches. And then we're going to wrap up today's video by looking at how we can save still images. So let's go ahead and pick up where we left off from last time. I'll run this so we can remember what it looks like. Great. And think about maybe one of the ways we might use variables in the sketch that we have here. So one kind of rule of thumb that you'll probably encounter in coding textbooks and forums is that if you're using a hard-coded value more than like three or more times, you probably want to use a variable. And you actually don't have to use it three times. You can use a variable basically anytime you want, but that's just sort of like a general rule of thumb. So if we look at our sketch here, you can see we've hard-coded the height of our shape, right? What is this? 1, 2, 3, 4, 5 times in the sketch. So that seems like something that I might want to come and use a variable instead of just hard-coding that. So to do that, we need to declare the type of the variable. We got to tell processing like what kind of information are we going to store inside of this variable. We need to give it a name, and then usually we want to make sure we initialize the variable just so that we don't run into any issues where it's an empty variable that the program is trying to use. So let's go up here above setup, and we'll declare an int or an integer, which is just a whole number. Let's name this one h because we're going to replace the height of our shapes here with h, and then let's initialize it just with the same value that we have in the sketch already. And then we're going to come in here and replace all of our hard-coded shape heights with this variable h that we've created. Awesome, and you can see it looks exactly the same, right? But what's so powerful about using this variable instead of these hard-coded values is that now I can come in here and I can change the value of this variable, and it will affect everything that I'm using the variable in without me having to go back and retype every single place it appears in the sketch, right? So now you can see these are much taller. If I come here and I instead write 100, you'll see they get a lot shorter. Cool. So another reason that variables are so powerful is that you can actually now change this value while the sketch is running, right? And so I could come in here, and we're going to look at now how we can get some mouse input really easily. So processing has another special set of special variables called mouse x and mouse y, right? So let's throw in a print line for a second and look at mouse x and mouse y, and let's just see what those return. What they're going to do is it's going to spit out the pixel that my mouse cursor is currently over in the display window. And so right now my mouse is not on the display window at all, and it also just initializes those values as 0. But as soon as I move the cursor onto the display window, you can see now I'm getting 11 for my x position, right? Because my cursor is over on the left side of the screen, and if I were to go up here, it'd be closer to 0, 0, right? As I increase the x position of the mouse, you can see that number gets bigger. As I increase the y position, that number gets bigger. And you can see the range of these variables is going to be between 0 and the width that I've declared in size, and 0 and the height that I've declared in size. And so in our case, it's going to be 0 to 640 and 0 to 480. So these are some really cool variables that come with processing that allow us to kind of control things with our mouse really easily. So now instead of just printing those values out, I could come in here and I could say h is equal to mouse, let's say y, right? So the height of my shapes is going to be equal to the y position of my mouse cursor on the screen. So I don't think I should see the shapes at all when it starts, right? Because it's 0. But if I then start to drag my mouse down, then my shapes grow and shrink. It's pretty cool. So let's do the same thing so we can maybe control the width of the shapes as well. So let's come up here and we'll say int w, and I think let's just throw in our original values 300 and 100. And then I can come over here and I can replace my width here. Here, remember, this was the width of our shape divided by 2. So I can just say W divided by 2, and then minus W divided by 2. Right? So this is now going to replace all of these with 100. And let's just see what that looks like. So it should behave exactly the same, but now we're using a variable instead of those hard-coded values. Great. Which again allows us to either change it in the initialization or update it during the sketch while the sketch is running. So let's make that width equal to mouse x and run our sketch. Okay, and now you can see I've got a little more control over how these shapes behave. And this is pretty cool. I mean, you know, just a couple of mouse inputs and we've already got a pretty cool playable visual. I'm sure if you were to turn on a piece of music or, you know, your favorite track, you could imagine yourself animating this to the music. And, you know, at this point, this is like a pretty cool little playable visual, and I might actually end up saving it so that I can just kind of play around with it and break the code and do different things without really having to worry about destroying this if I'm sort of happy with where I got this visual to. So let's go ahead and do that. We'll just hit Command S. And I'm just going to save this to my desktop. We'll call this 3 shapes 4 colors. How about version 1? Okay, awesome. So now you know how to use your own variables, and you also know how to get the X and Y position of the mouse cursor. Let's change gears for a second and look at how we are going to rotate shapes in our sketches. Let's see. So let's go over to here and take a look at a few things. So in processing, we are going to use the rotate function, right? So I would just write something like rotate, open parenthesis, and then I have to tell processing, like, you know, to what degree do I want to rotate? And this function is expecting that value, that argument, in radians, right? And so if you're not familiar with radians, there is a function, a radians function. You could just say radians, you know, and then if I want a 90-degree rotation, I can put in 90, and this will automatically translate 90 degrees into the equivalent value in radians, which is actually pi over 2. But let's go here and look at the unit circle really quick, just to kind of review so that we don't have to use this if we don't want to. So if you take a look at this circle, right, our unit circle over here on the right side at 0 degrees, right, when we travel around the circle 90 degrees, 180, 270, and 360 degrees, each of those is equal to some value between 0 and 2 times pi. So 90 degrees is equal to pi divided by 2, 180 degrees is equal to pi, 270 degrees is equal to 3/4 pi. Sorry, this is 3 over 2, not over 4. That's what I was missing. So 3 pi over 2, right? So this is 3 halves. And then this would be the 2 pi over on the right side. So that's just a little bit about how this unit circle works, and this just to kind of review how processing is expecting us to give it the amount of rotation. The other thing to know about this rotate function is that it's going to rotate the entire coordinate system around the origin, right? So if this is our sketch window here, and I say rotate, you know, pi divided by 4, which is 45 degrees, processing is going to take this whole entire coordinate system and rotate it like this from the origin, right? So let's take a look at what that means for us when we're trying to rotate shapes. Like, let's say I wanted to take this square and I wanted to draw it in the middle of the screen and I wanted to rotate it 45 degrees. To do that, I'm going to have to do some, if I just used the rotate, like if I just draw this square and then I use the rotate function, look at what happens. You know, so I drew the square in the middle and then I rotated by 45 degrees or pi over 4. It does not keep the square in the middle, right? And rotate it. It does rotate it 45 degrees, but the square is no longer where we wanted it to be. And so in order to get around that, we need to use the translate function, which is also going to act on the entire coordinate grid, right? So if I move my entire coordinate grid to the place that I want my shape to be, in this case in the center, right? So I might say translate width divided by 2, height divided by 2, right? This is an x and a y. Translate's going to move this entire coordinate grid by the amount I've put here and the amount I've put here in the x and the y axes, right? So it's going to move the coordinate system half of the width, and then it's going to move it half of the height, and then it's going to rotate by 90 degrees. And if I, instead of drawing the square in the center of the screen, I actually draw it at 0, 0 after applying those translations, I'm going to get the picture that I was looking for. So let's look at that again, right? So what I'm basically going to do is draw my shape at the origin, right? And then I'll use translate and rotate before I draw it to move this entire coordinate system to the place that I want, and then I'm going to draw this rectangle or this square around the origin. And that's how we can actually rotate shapes in processing. So then I would draw rect, right? 0, 0, and then shape width, shape height. And that would be the code to give me my rotation. Now, hang in here with me. There's one more thing we need to think about when we are using translate and rotate, and that is, the sort of additive nature of these functions, right? If I write translate width height divided by 2, my coordinate system is going to do that. And then if I rotate whatever, I draw something, and then I go into my code and I say, I'm thinking, oh, I want to draw another square, but instead of it being in the center, I want it to be, at 3/4 and the center of the y-axis, right? If I just write, width translate 3 times width divided by 4, it's going to actually take this coordinate system and move it like this, 3/4 of the width of our display window, not from 0 over here, right? Because it's already here, and whatever you do after is going to add into what you've already done, right? So to prevent that, what we use is the push matrix and pop matrix functions. And these two functions, when you have to use them in pairs, so you can't use a push matrix and then not have a pop matrix after it, and vice versa. You can't have a pop matrix and a push without a push matrix before it, right? But any translation and rotation that you do inside of a pair of push and pop matrix functions will be quarantined from the rest of the sketch. So anything that happens inside of these will not affect what comes afterward. So let's go back to our sketch here and see how we can implement rotating some of these shapes into the sketch. So let's start by giving ourselves, well, let's start with the rectangle, right? And actually, let's go back. We don't want this mouse input right now. Just using our regular variables there, or our static variables. And let's go and play around with our rect first. So let's put a push matrix and a pop matrix. And then let's go in here, right? And what we're going to do is, instead of going here, or instead of drawing the rectangle directly at this x and y, we are going to translate to that position. And then draw the rectangle around the origin. So we'll run this sketch right now just to see that everything should be the same. Nothing should have changed, right? And just to kind of show off how this translate function works, right? We can see that if you change the position here, you're moving to a different place, right? So you can move this shape around using translate and just drawing it at the origin. So now if I come in here and I say something like rotate quarter pi, which is another kind of special variable that processing has built in. I should get a 45-degree rotation on my, rectangle there. Excellent. I can also, if I don't want to say quarter pi, I can say pi divided by 4. But these quarter pi, half pi, pi, and 2 pi are such common values that we end up using that processing has them built in, right? So that way we're not actually having to do a division. This is just a constant, right, that we have built in for us. Great. So let's play around with rotating the rest of our shapes. So we'll do the same thing. We'll put a push matrix and a pop matrix around all of these. And we're going to come in here and we're going to say translate to here and here. We will draw this at the origin. And let's rotate this ellipse also by quarter pi. Cool. All right, so let's take a look now at our triangle. And actually, let's think about, drawing this triangle around the center of the screen, because we won't be able to take exactly the just 2 points, right? Or sorry, not the center of the screen, but around the origin. We're going to think about how we are drawing the triangle around the origin. So let's say I'm thinking about how to draw this triangle. I can basically say, I want the middle of my triangle to be here. And I know that, let's pretend like we're back for our previous example that I had on pen and paper, where the width of the shape is 2 units and the height of the shape is 4 units, right? So I know that I want my triangle to be 4 units tall, right? And I know that I want it to be 2 units wide. So I know my points are going to end up here, right? So I can basically just think about my first coordinate here is going to be negative shape height divided by 2. Negative shape height divided by 2. And then, sorry, that's the y coordinate. And then the x coordinate is just 0, right? Because I'm right here on the origin, 0. And then negative shape height divided by 2. This point would be, for x position, right, would be the width of the shape, positive, right, divided by 2. And then the y coordinate would be height of the shape divided by 2. And then this one would be the same thing, except that the width divided by 2 would be negative, and the height divided by 2 would remain the same, right? So that's the x and y coordinates of a triangle, or at least of this triangle that we have up here on the screen, drawn around the origin. So let's go back to our code, and what we're going to do is the same thing. We'll have push matrix and pop matrix. And then when we go into translate, we do want it to be at 4 times width divided by 5, and then height divided by 2. That'll be the center of the screen and the right side of the screen. But instead of drawing it at all these coordinates, we're going to draw it around the origin. So the first point is 0, and then I want to take my shape height, right? Negative shape height, which is what we were calling h up here, right? Divided by 2. And then that's the first point. The next point, the x position is just going to be the width of the shape divided by 2. The y position will be a positive height of the shape divided by 2. And that third point is going to be a negative width divided by 2. And the height of the shape divided by 2. Let's close this, and that should be good. And let's run the sketch just to make sure that this triangle still looks like it should. Okay, it's looking good. And now I'm going to be able to come in here and rotate the same way, quarter pi. Awesome. Okay, so now all three of my shapes, I have control over these rotations, right? And if I wanted to, I could, use a variable instead of these constants and kind of run those around. So let's look at how we're going to do that. And maybe I want to use my mouse to control this rotation, right? So we're going to need a different kind of variable because now we are in a place where we're going to need to use decimals, right? If you remember, like pi is 3.14, right? So we need to have a variable type that's going to allow us to store numbers with decimal points. And so those are called floats, or which is short for like floating point number. So let's create a float variable and name it angle. And for now, let's set it to 0, right? And then inside of all of these rotation functions, we'll just write angle. And so we should have, yeah, awesome. Okay. Now, if we wanted to use the mouse x and mouse y variables that we had from before to control our rotation, we're going to have to use another function called map. And the way that map works is that it's going to take some value that you have, that you know, right? So let's say like mouse x. For example, we know that mouse x goes from 0 all the way to 640, right? And so this is the range of values that we're going to get from mouse x, right? But we don't actually want to spit out 0 to 640. Like if we wanted to just be able to rotate our shapes 360 degrees, we really want to spit out values that are between 0 and like 6.28, right? That's roughly 2 pi, right? So, that would be this is not going to be to scale. But let's say 6.28 is somewhere around here, right? And so we only want to spit out values in between 0 and 2 pi, right, to do a full 360-degree rotation. So what map does is it takes some value that we know, mouse x, right, and we have to tell this function what's the range of the original value. It's going to go from 0 to 640, and then we got to tell it what range do we want to output instead, and we want to go from 0 to 2 pi, right? And so what this is going to do, when our mouse is at 0, this map function will spit out 0. When our mouse is at 640, it'll spit out 2 pi. When our mouse is, let's say our mouse is right in the middle of the screen at 320, the map function is going to come over here and do the math for us and say, well, what's in between exactly halfway 0 and 2 pi? Oh, well, it's pi, right? So I'll spit that out. And that's going to work for every single value. If I'm over here at a quarter of the screen, or if I'm over here at 3/4 of the screen, that map function is going to figure out where this value in the original range lies on the new range and spit out that value for you. And it'll do that anywhere on this new range. And this also outputs a floating point number. It does not give you, it returns a floating point number. It does not give you like an integer. So that's another reason that we're going to need this angle variable that we're using here to be a float, right? So let's come in here and let's say angle equals map mouse x, which we know goes between 0 and 640, between 0 and 2 times pi, right? And then we'll run our sketch, and you can see as I move my mouse left to right, I'm able to rotate my shapes 360 degrees, or any rotation in between. If we want to see that a little bit more explicitly, let's do this. Let's say print line mouse x and angle, right? So this will spit out what is the x value and what are we actually telling the rotation to be based on this map function that we've just used. So if I go in the center, I should get close to like 3.14. Can I get it? Oh, close. Okay, so I'm close to 3.14. And if I go all the way over here, I should get close to like 6.28. right? And so you can see this map function is spitting out all the values in between for us that we define. And so, this is a 360-degree rotation. What if I wanted to start at 180 and go to 360, or start at pi and go to 2 pi? I can also do that by just changing the range that I'm mapping here. And that can be super cool and fun. Okay, great. So now you know how to get some mouse input, you know how to rotate and translate your shapes, you know how to use your own variables. Let's wrap up today's video by looking at how we can save some still images. So in order to do that, you have to have saved your project, which I think we did a little bit earlier. But as long as you've done that, then processing will have created a sketch folder for you, which is going to contain the sketch itself, and then it will output any pictures or still images that you create to this folder. So the simplest way to do that is to just write save at the end of draw, and let's give it a name, 3shapes4colors.jpg. And now at the end of every draw cycle, it's going to save a copy of the display window, and it's going to name it this. And you can see here, it basically overwrites it every single time. But I've got this JPEG now of the very last frame before I exited my sketch, right? And you might have noticed that it also kind of slowed the sketch down. It was a little bit glitchy, and that's because this is having to save a picture every single time that we run our sketch. So we might say, actually, I don't want to do that every single time. We're going to use another special kind of code loop that comes with processing called mouse pressed. And this is just going to listen for any time we're clicking inside of that window. And anytime we click inside of the sketch window, the code inside of this loop, right, the mouse pressed loop inside these curly brackets will run. So I can take this save function and move it to mouse pressed. And then when I run my sketch, I should be able to see it's running a lot smoother now, and it's only when I click will it save a new picture. Right, so you can see that here. And if I come over here and I click, now it's this one. Let's say I wanted it to be like sideways like this. I click, and it saves a new version, right? If you want to save a bunch of frames in a row, what you can do is instead of using save, you can use save frame at the end of every draw, and then run the sketch. And then when you exit the sketch and go back to your sketch folder, you'll see that it automatically output a bunch of different, well, I guess I need to let it load, right? It output a bunch of different differently named screen captures. And then here, what I can do is processing has a built-in movie maker tool. So this thing here, what I can do is I can come in here and I can put all these into a folder. And we'll just call this 3shapes4colors frames, right? And then I can say, go to this folder and use all of these, right? Create movie. Put it in here, and we'll call it 3shapes4colors movie. And then I should have this thing here, and very fast. It's only a couple of seconds, but now we've got this little movie clip. Cool. All right. So join me in the next video where we learn how to spice this up even more.